Okay, so let us investigate how we will use the inverse matrix method to discover the equation of a line given 2 points. So first we want to start off with the fact that y equals mx plus b is given to us. Okay, so y equals mx plus b. They've given us 2 points, -1, 8, which we know is an x and a y, and we've given us a 3, 4, which provide us with an x and y coordinate. So let's rewrite this equation using these x and y coordinates. But what I'm going to suggest is I'm going to move this y over to the other side. Okay? And you'll see why it's more pleasing to the eye when it comes to setting these up in matrix equation form. So let's substitute these into there. So we're looking for m and b. Okay, y equals mx plus b is the equation we're trying to establish. So m and b are our unknowns. So we'll substitute the x and the y into this equation. So we have m times -1 plus b equals an 8. And then we have the m times a +3 plus b equals a 4. Rewriting this in matrix form, we'll write down the coefficients of slope, the coefficients of your y-intercept, and we're multiplying this 2 by 2 matrix by a 2 by 1 matrix, which are the variables m and b, and we're going to set it equal to our y, 8, 4. So if you multiply the row by the column, let me highlight here a second, this row by this column, you would get this equation here at the top, and which, obviously will equal that 8. And then another color here, if you multiply this row by this column, you'll get the second equation, which is this right here. Okay, so I just wanted to make sure you can visualize that. Okay, now what we need to do is we're solving for m and b. So what is needed to happen is that we need to isolate it by multiplying either side of this equation by the inverse of the matrix we're trying to move. Okay, so I'm going to multiply this matrix by its inverse. On this side, and whatever I do on one side, I've got to do it on the other side as well. Okay. And we do that because, oh my goodness, I completely forgot. Way too funny. Right in here, I did forget our m and b matrix. My apologies about that. So we do that because this right here is going to become our identity matrix. Okay? What you guys like to say, it cancels out. But what we did there is purposely multiplied both sides by the identity matrix to isolate the m and b matrix that I had forgotten to write. Okay, so now that the m and b matrix here, this 2 by 1 matrix, is isolated, we just have to evaluate, and you can use your calculator here if you're not required to do it by hand. Plug this into your graphing calculator, and once you have plugged that in, you'll be able to find that the m and b are equal to -1 and a 7. So our final answer would be y equals -1x plus 7. And you can double check to make sure that this is correct by plugging in your x and y coordinates in there. So, originally there we had the x and y was negative 1 and 8. Well, 8 equals negative 1 plus 7. Well, 8 does equal positive 1 plus 7. And it works also for the other point. Also, it can be done where you guys can, let's see here, if I can bring it up for a second, where we can, oh, it's not going to happen, but let me see. If I were going to give you 3 points, let me get some 3 points here. Okay, how about if we were asking to find the quadratic equation? Okay, so if we're finding the quadratic equation, we are going to use the equation ax squared plus bx plus c equals y. You would do the same thing. This time you're substituting your x, and so you are going to substitute the negative 1 squared plus b times negative 1 plus c equals the 8. If your point was negative 1 comma 8. If we had a point 1 comma negative 2, we would do the same thing again. So it's slightly different, more numbers than the linear equation, but it still works out. Let's say our last point is 3 comma 4. So we've plugged in every x and y. So let's take these 3 equations and rewrite them in matrix form. So notice in this case, you're going to end up with a 3 by 3 matrix. So we need to make sure you notice here that we need the coefficient of a. So we have to take negative 1 to the second power. That is just going to be a positive 1. And then we have to do 1 to the second power is a 1. 3 to the second power is a 9. And then we'll do the next thing again. Go to the next part here. Take the coefficients of our b. Well, those are not squared, so we will just merely write down what we see there. Negative 1, 1, and 3. And then we find the coefficients of our c. Well, the coefficient of our c was just a positive 1. So we'll put a 1, and a 1. And these are multiplying by ABC. And we're setting them equal to the y, negative 2, and 4. And just like the linear equation, you are going to multiply both sides by the inverse matrix of this one. Okay? So I'm going to say multiply by inverse matrix on both sides. I won't write it out this time. And once you do that, you will be able to isolate the ABC, which are the coefficients we're looking for. The inverse matrix on this side will multiply by the y values. 8, negative 2, and 4. And I forgot to put my inverse symbol here. So please don't forget that. And again, using your calculator, unless you're required to do it by hand, enter those matrices, and you will end up with A being a 2, a negative 5, and a 1. So in essence, y equals 2x squared minus 5x plus 1. If you want to check, we can check with 1 point. Let's check with 3, 4. So 4 equals 2 times 3 squared minus 5 times 3 plus 1. Let's put a big question mark here. Let's see if it does work. So does 4 equals 2 times, well, this here is going to be a 9, so 18 minus 15 plus 1. Well, does 4 equals 18 minus 5 is a 3 plus 1? It sure does.